Welcome back to the second part of this conditional probability lesson. So hopefully you tried some of these questions out before we start. If not, pause the video, try them out, come right back. All right. So this first one here is just asking us to find the probabilities. Like Nathan and Riley are playing this game. They chose a number 1 to 40. And then Riel, I kind of spelled it wrong in that picture there compared to the one above it, says that the number he chose is a multiple of 4. So he's giving them a condition already, like an event. Then what you want to do is we want to know what is the probability. Let's just let's give it a couple statements here. Let's just say event A is the mult of 4, and let's say event B is a mult of 6. So remember the multiples of 4 and the multiple of 6, like 4, 8, 12, 16, etc. Or multiples of 6 would be 6, 12, 18, 24, right? So you just give an adding 6 or adding 4 each time. So those are the numbers, right? Now, what we want to know, what they're trying to say is, what is the probability, because there's the last line here, what is the probability that it is a multiple of 6 if I already know that it's a multiple of A? That's what I want. So let's just go through the logic of this and say, okay, how would I calculate this? What would I do to find out one, and then I can find out the other? Okay. So if I were to think about this as a tree, or you could think of it as a Venn diagram, there's lots of different ways to do this, but I can think of this as a tree because that's the way we've been doing these, is first of all, what is the probability of it being a multiple of 4 to start off with, because that's what he decided. What's this probability of it being a multiple of 4? Right? So to be a multiple of 4, you have to be a bunch of different numbers. And maybe by drawing a Venn diagram, we can actually see the numbers of the multiples of 4 compared to a multiples of 6. But to be a multiple of 4, I have, if I were to draw this out, there's a Venn diagram here. Okay. I have 4, 8, 12, and I put a 12 here because this is the multiples of 4. This is the multiples of, let's call this A here, sorry, so the numbers don't get mixed up. So, and this is the multiples of 6, and 12 is a multiple of 6 as well, so it's kind of in the middle there. And then I got 16, 20, and then I got 24, which is also a multiple of 6. Then I have 28, then I have 30, and then I have 36, which is also a multiple of 6. And then I have 40. And then over here on the multiples of 6 side, the numbers that I don't have right now are 6, 18, and 30. And then I have some numbers on the outside here, like 1, 2, 3, etc. Okay, so we create our list here. This is what we have. The probability of grabbing a multiple of 4, because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is 10 out of 40 numbers. Because there's 40 numbers in my whole universal set that I can choose from. But there's only 10 that are multiples of 4. To be not a multiple of 4, so this is and this one's not, would just be the other numbers, so 30 over 4. Okay, I'm not too concerned about this side down here. Okay, so now that I've discovered that it's a multiple of 4, so now I'm inside of this box here, my sample set is decreased significantly now. Because my sample set now is decreased, that's why it's conditional. So that's why now for this one, my sample size is only 10 large, because I've decided, okay, I pulled a number that's one of the 10 out of 40. Now, out of the 10, what's the chances that 3 of them are a multiple of 6 as well? Well, sorry, what are the chances of the multiples of 6? And there's 3 of them. You can see here there's 3 of the 10 in this box here that I've drawn for A. So I've decided I'm inside this box now. There are only 3 of them that are also multiples of that. And then you can go down here and say, okay, there's 7 that are not. But again, I'm only worried about this situation. I'm worried about this one right here. that is the probability that it is a multiple of 6 if I already know it's a multiple of 4. So that's that probability there. There's a few different ways to do it. You can do that by the tree diagram. You can go over here to the Venn diagram and say, okay, I know I'm in this circle because that's one of my conditions. There's 3 of the 10. So you can say there's 3 here, but the circle has 10 in it. So 3 out of 10, right? I do like the tree way. You could try to do this by the formula as well. When you try to do it by the formula, it gets a little bit trickier, but we can still do it. Just have to double check. We can. Yeah, we can. Okay. So to do this by the formula, maybe like this. Okay. So the probability that it is an A and a B at the same time is going to be the probability that A happened times the probability that B happens as long as A has happened, because they are not mutually exclusive here. So they are conditional on each other. So I'm going to rearrange this for this piece over here. So I'm just going to leave that on that side. I'm going to divide the PA, the probability of A happening. Sorry, I kind of switched that around by accident. Down to the other side here. Okay, so the probability that A and B are going to be polled at the same time is going to be, there's 3 of them out of the whole 40. So the top here is going to be 3 out of 40. And the probability of A happening, this is A here, the circle, the red circle I drew, is there's 10 of them out of the 40. And if I do the math on this, I can have 3 over 40. And then when I divide by a fraction, remember when I have rational expressions, if I divide by a fraction, I take the reciprocal of it, becomes 40 over 10. You notice that those 40s, one on the top, one on the bottom, they cancel each other out. And you also get 3 over 10 again. So there's 3 different ways to do the same question. So the next one here, there are 75 males, 90 females in a graduating class. Of them, 40 males and 55 females plan to attend University of Alberta next year. Determine the probability that the randomly selected student plans to attend university. Okay, so the probability that they plan to attend, so that's just going to be PA, let's just call that. Plans to attend U of A. Kind of weird spot to put that A. Let's put that over here. Let's call this event A. Okay. The probability this will happen is going to be the number of kids that are favorable. So I'm just going to add these two together. Let's just write out the formula first, and then divided by the number in the sample space. So I'm going to add the kids that are going. I'm going to add the kids that we have, the total sample space here, and then we're going to divide the 2. So we got 95 kids going out of 165 total students. Just going to kind of reduce that down to 19 over 33. Okay, a randomly selected student plans to go to university, so we have that already. Determine the probability that that student is also a male student. So I want to know, let's just call this event B. I want to know what's the probability of event B happening if I already know that A has already happened. So because I've done A, my sample set has decreased down to 95 kids, right? So my sample space has changed. This is my new sample space. So it's not going to be 65. It's going to be 95 because those are all the kids that are going, new sample space. Now, of that sample space, 40 of them are male students. And then I can just reduce this down to 8 over 19. There you go. Right. There's a few other ways. You can go up there and do like a Venn diagram. You can do it by the formula. That's probably just the easiest way to think about how this works, because that's how these other ones change. Like if I know this one, if I know that this happened, this changed that sample space. Right? So same thing, if I know this happened, this sample space was right here, and I use that sample space down here to do this one. Oops, hit the wrong button on my keyboard. I was just trying to erase this line. All right. Here, Elaine likes to go for daily jogs with her dog. All right. If the weather is nice, there's a 95% chance she'll jog the 5K. If it's rainy, she'll only 50% chance that she'll jog. The weather forecast says that there's a 35% chance of the rain. What's the probability that she will actually go for the jog? So I want to know the probability here. This is what we're looking for. Probability going for a jog. In this case, the probability of going for a jog and just the probability of going for a jog. All right, that's all I want to know. Okay. So to figure this out, I'm going to just draw a tree. What is the probability of it raining? All right. So the probability of it raining, let's say yes, it is going to rain on the top here. It's going to rain 35% of the time, right? Nope. Then it's not going to rain 65% down here. So it's going to be a nice day. It's going to be a rainy day at the top. Okay. Then what I'm going to do is that if it's raining, it says up here, if the weather's nice or if it's rainy, there's only a 50% chance that she'll actually go for a jog, right? So she'll go for a jog 50% of the time. And then I'm going to say, nope, down here, the other 50% of the time. So that's the top part. If it's a nice day, this is just a nice day, she's going to go for a jog 95% of the time. And then we're going to do a little nope of the other 5%. Okay, so we did a tree like this before to find all the different pieces, but really, I just want to find out when does she actually go for a jog. She goes for a jog here, and she goes for a jog here. So those two lines on my tree. Now to find those two lines in the tree, I'm going to take the probability of it raining, and then times it by the probability that she goes for a jog if it's raining. Okay. Down here, I do the probability of it not raining times the probability to go for a jog when it's not raining, because I'm using that complement symbol there. It stands for not. It's just simple little math, or a simple little symbol there for notation. I'm going to just multiply these together. So I have 35% times 50%. Now you're going to put these into decimals, like 0.35 times 0.5, and we're going to get 0.175 for that one. And then the same thing on this one, we're going to do 0.65 times 0.95, and I'm going to get 0.6175. Okay? Because those are all the times she goes for a jog, I'm going to add those together, and I'm going to get 0.7925. And I'll just change it back into a percentage here. Doesn't specify how many decimals to go, so I'll just say 1 decimal place there. So there's a 79.3% chance she will go for a jog, 5K jog. Okay, let's go to the next side here. So we got some typical kind of test questions you might see. Actually, all these kind of questions I've been asking are test kind of questions, so I don't know why I put that there. Let's just see what we have here. So the probability the plane will leave Saskatoon on time is 85%, or 0.85. The probability the plane will leave Saskatoon on time and arrive on Vancouver at the same time, is about 70%. The percent probability that the plane will arrive in Vancouver on time, given that it's already left Saskatoon on time, is what? So I want to know this. What is the probability that it will arrive in Vancouver on time if it left Saskatoon on time already? So we already know that event has happened. So what we know so far Well, I'm just going to write up the formula here. Now we know it's left Saskatoon on time. And I want to know the probability of it leaving Saskatoon on time, or arriving at Vancouver on time if it's left Saskatoon on time. So I'm going to rearrange this equation for what I'm looking for. So I'm looking for this conditional probability here. And then I'm going to see if I have the pieces I need to put in here. So what do we have? The probability that the plane leaves Saskatoon on time and arrives at Vancouver on time is 0.7. So that's this and one here. So this is the intersection. So I know that number, the top number there. And the bottom one here is just what's the probability of leaving Saskatoon on time? Well, that's that top one there. So this is PS here. And this one here is P, V, and S at the same time. Okay? So divide that 0.85. Divide those two numbers and you get 0.824. So that's the probability that it'll arrive on Vancouver on time if it's less Saskatoon on time already. There. Okay. Here's a nice little review question for the next video technically, but I might as well just do it for this video. I want you to try to solve this. You could solve this by using a tree, very similar to that kind of raining question. So if you haven't tried this question already, give it the video pause, draw out a tree, and then answer the question, what's the probability that the Cougars will lose on Thursday? And the Cougars will win on Thursday as well. Okay, so hopefully you pause and hopefully you actually try this question. Let's go through it, just very similar to the jogging question we had here. If it rains, what's the probability of it raining? What's the probability of being nice? And then I'm going to just put some percentages in there that we know. So there's a 25% chance of raining, so therefore it's a 75% chance of being nice. Okay, and then in each of these cases you have a condition of winning or losing. Okay, based on the record, it's 50% chance of winning on a rainy day. So she only has a 50% chance of winning on a rainy day, and 70% chance of winning on a sunny day. So that's what we know. So that means there's a 50-50 chance of losing as well, and there's only a 30% chance of losing on a nice day. So I'm going to continue on, but really all I want to find for this is when will they win? So I want to know this line and that line. So very similar to that jogging question, I'm just going to multiply our two percentages together. So 50% of 25% ends up being 12.5%. And then 75 of 70 ends up being 52.5. So I'm just multiply those. And what I'm going to do is I'm going to add those together. So the probability of winning is 65%. Okay. Now, you can go through this tree and actually just find these other two numbers here. But what we know is that if you don't win, you've lost, right? So probably not winning, that's what this means. Remember, this little symbol means not, means you've lost. That also just means I'm going to go 100% minus the 65 I already have. So there's a 35% chance that they're going to lose. Now, if you want to verify to see if that actually works, you look at this tree here and find the bottom pieces this time. And you could do that. So if I want to just figure that out really quickly, this is also 12.5% for that one. I'm just going to mention I'm adding those together for this top question. The bottom one, 0.3 times 0.75, there's a 22.5%. So 12.5 plus the 22.5 is 35%. So it worked out. Okay, so in the next video, we're going to talk about our independent video or independent events. So continue working on those practice sheets that I gave you, and I'll see you in the next video. Bye.